Now let's look at number 11. Number 11 says that a 5 kilograms object attached to a spring with a force constant of 8 newtons per meter vibrates in a simple harmonic motion with an amplitude of 10 centimeters. Calculate part A, the maximum value of its speed and acceleration. B, the speed and acceleration when the object is 6 centimeters from the equilibrium position. And C, the time interval required for the object to move from x equal to 0 to x equals to 8 centimeters. So that's the diagram, the graph of the problem. To do number A, which is to find the maximum value of the speed and the acceleration, we need to first find angular frequency. Angular frequency at w squared or omega squared equals to k over m, and w equals to 0 square root k over m. In this case, k is 8 newtons per meters and 0.5 kilograms. Omega will be 4 radians per second. And let's now write the equation for x. Xt equals to the amplitude times cosine 4t. Now we know that the maximum velocity, is omega times amplitude. In this case, it will be 4 radians per second times 0.1 meters equals to 0.4 meters per second. Now the maximum acceleration is w squared times a, which is 16 radians square per second squared times 0.1 meters, which is 1.6 meters per second squared. So that's the acceleration. Now the part B, let's write the equation first. Now the given distance is 0.06 meters. We do this in order to find the time that it takes to travel this much distance. So, and we will get the time to be 0.232 seconds. Now we plug in this time to the velocity and acceleration separately to find velocity and acceleration. So that's the equation for velocity, 4t. V then equals to 0.32 meters per second. The equation for acceleration is 1.6 cosine 4t. And now we plug in a t, a will become 0.96 meters per second squared. And that's part B. Now let's try C. The C asks us to find the time interval required for the objects to move from 0 to 8 centimeters. That's the equation for the x, cosine 4t. Now, let's set 2 points. And what we need to do is that we need to find the time it takes to reach these 2 points. And we subtract the time to get the interval. So the first one, when 0, cosine 4t, we'll get t1 is 0.393 seconds. The second one, which is 0.08 meters, the other end of the interval, and we set that equals to 0.1 cosine 4t. In this case, t2, we get 0.161 seconds. So, the time interval is the difference between these two times. So, t1 minus t2, which is about 0.2 0.32 seconds. And that's the entire problem.